Okay, Putte. Today we are going to learn how to speak computers. Do computers speak? Did you know that computers don't actually understand Sinhala, Tamil or English? Right? When you type a letter or take a photo, the computer doesn't see the way you do it. Right? Look at this. Here, this is the user and this is the computer. When the user says hello, computer hears numbers. No? Specifically, a string of zeros and ones. So, today we are going to learn how to decode that language. Okay, Putte, welcome to number systems. All right. First, what is a number system? Hmm. What is a number system? Simply, it is a method used to represent numbers, right? A number system is a method used to represent numbers. Understood? So, every number system has two main features, a set of symbols and a base, right? I think you have already learned this in math class. Okay. Look at here. You can see there are two symbols for binary system, right? This is the binary system. There are two symbols here. So the base is 2, right? So here in the decimal number system, you can see there are 10 different symbols, right? So the base is 10. Putte, the decimal number system is what we use in our math class for our um, calculations, right? So, okay. So, if the base is 8, how many symbols should be there? 8 symbols, no? So, we called it octal number system, right? This is the hexadecimal number system. You can see the base is 16, right? So, after 9, you can see other symbols here as English capital letters, right? After 9 starts English letters, right? So, Putte, here we will focus on only on binary and decimal, right? So, before moving to the next part, who can differentiate binary and decimal systems? Simply, decimal number system has 10 symbols, 0 to 9. Decimal number system is what humans use for calculations, right? So, binary number system has only two symbols, 0 and 1. It is what computers use, all right? So, now let's have a quick review about the decimal number system. Putte, we use the decimal system for arithmetic because it's familiar to humans, right? But how is a number form? It uses place value as you learned in your childhood in primary classes. So, can you remember the counting frame? We represented numbers in on a counting frame in our primary classes, no? So, okay, Putte. Let's break down the number 231, right? The 1 is in ones place, right? Ones place. Ones place means 10 to the power 0, right? Powers of 10. Why do we take powers of tens? Because the base is 10, right? So, ones place means 10 to the power 0. So, what is next? 3 is in tens place, right? It means 10 to the power 1. And 2 is in hundreds place. It means 10 to the power 2, right? Those are the place values of decimal symbols. So mathematically, it looks like this, right? So 2 multiplied by 10 to the power 2. It means 100. 3 multiplied by its place. What is the place? Tens place. 10 to the power 1. 10 to the power 1 means 10, right? 1 multiplied by 1's place. 10 to the power 0. 10 to the power 0 means 1. So, now add them all together. Here, 231. Right? The answer. Pute, notice the little 10 at the bottom right corner. This little 10. What is that? This subscript tells us the base is 10, right? This is the base. Here in binary number system, we should mention the base here, right? Octal number system, base is 8. Like that, right? So, okay, Putte. Now let's switch to the computer's word, the binary number system, all right? So, you know, binary number system has two different symbols, only 0 and 1, no? So, we call them bits, right? 0 and 1 are called bits, right? B from binary, it from digit, right? Bit. So, 0 and 1 are bits, right? So, this is how we represent binary numbers on a counting frame, right? Same as decimal number system. Here the base is 2, right? So, we take powers of 2, right? So, you can see here 2 to the power 0, 2 to the power 1, 2 to the power 2, right? This is the binary value, right? Simply, just like decimal uses powers of 10, binary uses powers of 2, right? So, let's look at the number 101 base 2. Here, 1 is in 2 to the power 0's place. 0 is in 2 to the power 1's place. And this 1 is in 2 to the power 2's place, right? Here, leftmost 1 multiplied by 2 to the power 2, right? 2 to the power 2 means 4, right? 2 to the power 2 means 2 multiplied by 2, right? So the answer is 4. 0 multiplied by 2 to the power 1, right? 2 to the power 1 means 2. And here, the rightmost 1 multiplied by 2 to the power 0, right? 2 to the power 0 means 1. So add all together. Here the decimal value, right? Here is the decimal value, right? So, another way to do this conversion, we can do like this, right? Here, see, this 1 is in 2 to the power 0's place, right? You should multiply this 1 from by 2 to the power 0, right? So this 0 multiplied by 2 to the power 1. Here, next 0, right? 0 should be multiplied by 2 to the power 2, right? So on. And you can see here power values, right? And next, add all together, right? 1, 0, 0, 8, 16, 0, 40, sorry, 64, 128. Add all together, then you will get 270, right? That is the answer. We also can convert binary to decimal like this, right? This means 101 base 2 in computer language is actually the number 5 in our language, right? So, okay. Now let's learn how to turn a regular number like 13 into binary, decimal to binary conversion. So, what is the base of the binary now? Numbers? 2, right? So, we should divide by 2 continuously until it becomes 0, right? Until the value becomes 0, right? Because we need to convert it to binary value, right? So, 13 divided by 2, we have 6. And what is the remaining? 1. We should mention the remaining value here, right? And you should divide 6 by 2 again, right? We get number 3. The remaining is 0 now, right? We should We must mention it here, right? So next, 3 divided by 2. Now we have 1, and here is the remaining 1. And finally, 1 divided by 2, value became 0. The remaining is 1, right? To get the binary number, you should write down these numbers bottom to top, right? Bottom to top, like this, right? So this is how we convert decimal to binary, right? So, okay, Puttu. Here you can see a user. The user is typing number 9, right? The user has typed number 9. You know, he is giving input in decimal number system, right? But you know now, computers can't understand humans' language, right? Decimal number system, right? So, it should be converted to the binary number system to understand, right? So, this you can see here, you can see the CPU is there, right? CPU is not the system unit, right? Inside the system unit, you can see the motherboard. CPU is located on that, right? So, we can't see it outside, right? So, CPU convert, right? Convert that number to binary number system like this, right? Importance of conversion from one number to another number, right? Okay, Putte, you can see here there are several file types here. This is an image, this is an audio, this is a letter, right? This is a number, decimal number, right? So, how does a computer understand these data? All these should be converted to the binary form like this, right? We discussed these earlier. As the input, we give data as text, images, and sound, right? And it can be a decimal number because it is the number system we use, right? A number system familiar to the humans, right? After giving data, the processor, right? Processor means CPU, Central Processing Unit, right? It processes data in binary form, right? Then computer can understand data. So after, if when we need an output, right? Right? It converts from binary to decimal again, right? And the other thing is in computer, in information technology, all processes in a computer are performed using 0 and 1, right? Putte, think about a switch, right? 0 means switch off, 1 means switch on, right? The computer uses on and off to represent the data and instructions as a bit pattern of ones and zeros, right? On means 1, off means 0, right? So, this is the end of today's session. Pute, see you next day, right?